I'm Tim Silverline. I'm the VP Security of Gluware. I joined back in November of last year, really to help Gluware enter the cybersecurity space. And Gluware has done intelligent network automation for some time, and obviously there's a lot of crossover elements from the network into security. But we're really looking to step forward in that space and have some really exciting solutions coming to bear over the next year or so. Today, we're here to talk a little bit kind of about our first little tiptoe into the cybersecurity space, leveraging our new product, Network RPA, to show some automated security response. Real quick, as just a background to me, so I've been in the California area for a while, helping a few different companies build their cybersecurity practices, and really have been in the network and security space for about 20 years, helping customers design and implement cybersecurity solutions. So we kind of saw a little bit of this slide earlier from Mike about our overall architecture. And today we're going to really show how we can operate and integrate northbound with some technologies to give us some security alerts, and then operate southbound into API-based environments as well as CLI environments to take automated response. So one of the things that API or Network RPA really gave to us was the ability to take in external driven events, specifically from APIs, to really handle some really cool automation. Presenting at ONUG last week, we demonstrated our first integration from this perspective. And it was focused around taking in an event via the Cloud Security Notification Framework, CSNF, via an alert that was generated from Microsoft's Azure Sentinel product, which is their security analytics product, or SIM. What we were demonstrating in our demo is a couple of different actions to take inside of the environment. The first one is something that Mike has already demonstrated for us today, is the ability for Network RPA to go ahead and conduct a drift on the configurations from the equipment that it's monitoring and managing. And the second is to conduct an audit to determine whether or not that configuration is in line with the compliance standards of the company. The thing that we added to this for ONUG, which was kind of cool, and really the integration with Microsoft, was the ability to take in an IP address from what they've determined to be a bad actor, and automating the response around an ACL inside of our AWS cloud environment to block further communication from that bad actor. And then another thing that we added into the demo this week is the ability to use Ansible to do some testing inside of the environment, and really showcasing our integration with that third-party solutions to do some additional advanced automation capability and technologies. So real quick, just to show you some basic information about the environment that I'm conducting the demonstration in, is I just built a basic small AWS VPC with 2 different EC2 instances in it. One of them is operating as the target computer, or where the application resides that is theoretically being attacked. And the second one demonstrates here the public user, or the user that would be attacking from outside in the internet that's trying to do something malicious in the environment. Really quick, I'll show you here. We have 2 different ACLs inside of this AWS VPC. One of them is specific to our application server, and the other one is just a generic default subnet ACL. Both of these right now don't have any rules of them. They're just the basic ones that come with the default ACL, which is just permit any, and then a cleanup rule at the end. But that's the environment that we're looking at doing this in today. So let me jump real quick into my Gluware instance here. Show you a real quick dashboard. So just to be clear, we already saw this from Mike's demo, but the same Gluware interface that we're used to doing for all the other tasks that we're so used to with Gluware today is all available in the same interface, and you have the capability of layering RPA on top of it. So I'm going to go into my workflow library here and find the one that I generated for this particular event, and walk through kind of how it's built, and the ease of the ability to interact with it and make changes and things like that. So here you can see my workflow laid out. It starts very similarly to how Mike did his, where we're filtering targets, and we're going to run the activity on a specific group of targets. And then we're going to go ahead and do the same activity that Mike showed as well in the beginning, which is we're going to capture the configuration of a select group of targets, and you're going to conduct a drift against them by comparing their snapshots together. And we walked through this if-then-else logic already, but basically the logic here is that if the config is drifted, we're going to go ahead and reprovision and remediate back to a known good configuration state. If not, we're going to go ahead and move forward. and then conduct an audit in the environment to see whether or not the configuration that exists matches our security requirements or compliance requirements from within the company. And go ahead and send information, email notifications about the results of those as well. And then we're going to go on to the actual automated security response inside of our cloud environment as well here. So the playbooks that you see here in RPA, or the ones that are titled playbooks, are specifically Ansible playbooks that we created just to test connectivity from the simulated attacker's computer over to the application server. And so what we can see here in the workflow is that the first step in the playbook is we're just verifying that connectivity is successful initially. Then we're going ahead and taking the action to call out and insert an ACL entry, blocking the bad actor from connecting to it. And then we run the playbook again just to verify that connectivity has been blocked, finally sending an email notification of everything that's happened. As we talked about, different external APIs can be used to generate these workflows. Now, what I can do, there's a couple of things I could do, is I could just kick the validation off from in here. But what I'm actually going to do is go ahead and demonstrate how this could be called from an external entity. And again, we demonstrated via the CSNF that Microsoft Sentinel could be calling this. For this particular demo, I'm just going to use an application called ARC, which is simulating an API call. So just going to go ahead and create a post condition, which I've had before, which is calling out this workflow in Gluware. And I'm going to go ahead and kick it off. So back in the Gluware control system, I can see on my workflow activity page, this one will take a little bit longer to run as we're calling out several different processes, but you can see real here the view from in here, what it's calling. So since we're using StackStorm for these integrations, we also get some visibility from within StackStorm itself. Yeah, so as Mike mentioned earlier, StackStorm gives us the capability of integrating with over 150 different external APIs out of the box. And you can see here on the left some of these that have already been installed for the demo, but you can see that there's a ton more of options that we can integrate with just directly out of the box. And StackStorm makes it really easy to do so because they have already all the unique fields and everything built into these integrations. Today, what we're doing is, again, we're doing some Ansible and we're doing some AWS. So see in the actions here, like all of the different options that you can do in AWS. It pretty much matches almost to the entire API, the public-based API. So any of the actions you can conduct via APIs, you can do via our StackStorm integration. Let's go back to history and see. Okay, so we can see the 3 tasks that got kicked off via StackStorm from our workflow. Here's the first one right here. And we can see the live output here. What we should be seeing is the ping that was kicked off via our host. And you can see here that 3 packets were received and transmitted, giving us a full success. And you can see our application is up. The next task that got kicked off here via our workflow is our API call to go ahead and insert an ACL entry blocking our simulated bad actor. And again, this is a variable that would be able to be received via the CSNF as it's being generated from a SIM. So if you had something like a specific actor that was just targeting your company, a lot of times that stuff's not going to be bubbled up through the threat intelligence agencies. You're not going to get that. So what the use case here would be, threat actors targeting your individual company is setting off the security threats or triggers within your SIM environment, but it's not attacking the rest of the rest of the globe. So it's not being automatically blocked by the regular feed updates you might receive from your threat intelligence provider. This sort of detection would be able to detect that inside of your environment and update your own internal systems to block that stuff from you afterwards. And I'll go ahead and show in Amazon here where that change is actually made. We were looking at these inbound rules here before. So if we go ahead and refresh this page, should see that there was a rule added here at number 10. And go ahead and we're blocking ICMP. I mean, normally if it's a bad actor, you'd probably block all IP traffic, but for the purposes of this test, we're just demonstrating that you could be very granular and specific and only block the protocol they're attacking with, or just end up blocking all the IP addresses or all of the traffic from their source IP address. So that really wraps up, I mean, kind of what we're doing here with the demo. We go back to close this. You can see that the task completed successfully. It took a total of 51 seconds to call out to all those different sources.
Perhaps a more general question about the workflows in general. If you create your own drag and drop workflow, can you embed other workflows that you've created as actions? Like, so I guess, can you nest workflows?
Yeah, the answer to that is that's not something we're capable of doing right now. RPA is very early in its release, and I imagine that's something that we're probably going to be asked about in the future. But today we're not able to do nested workflows.
So you can't have like a workflow that's called by another workflow?
Not today.
Okay.
Yeah, actually, so you could have separate workflows, and that because workflows can be called via API, you could have a workflow calling another workflow for sure. So, but what, and you can have the logic of it kind of branch into, different trains, but you can't, I guess we'd have to really define what you're saying by like a nested workflow. But
for example, we can't do a workflow that has additional variables for that workflow. So I have a workflow calls another workflow, and that is customized in the same way I would customize another calling to any other tool or process.
So I did not fully follow that, but what I would say is that the workflows support input variables and then output variables. So we definitely can take the output of an action or a variable, and in fact, we did it in this one. We can take the output of, like, let's say the ping test that was run in Ansible, or we could take the output of the AWS action and then take another action based on the output. So we definitely have kind of like the input output variable handling.
So I can input variables into a workflow. So what is it that I can't do when you say nested workflow?
Well, in the workflow builder, you can't go pick the workflow that you built and drag it and drop it into that.
Yeah,
so
that's what I was thinking.
Kind of a big deal, because let's say that you have a workflow that has a for loop, and in the for loop, you want to pass variables to another sub workflow. That's a big part of low code automation systems. So
Sure, your mic's on.
My mic's on. So I think we're just having a terminology problem.
okay, yeah.
Right? If you have a workflow that terminates with a variable you want to pass to another workflow all day long, right? We're not calling it nested. It's just another workflow that you're calling. Right. So if you have a workflow that does 5 things and it ends up in a fork, A or B, and you want A to go to another workflow and B to go to another workflow, that's not an issue. We can handle that.
So that's done. Is that done through kind of that third-party API call where we're saying, here's the API call. Here,
depending on the task you want to do, yes, it can be done that way.
but it's not. I can't go into.
You don't have it as a drag and drop item builder in the GUI today. You have to do it via an API call that starts the beginning of some other workflow that you could then.
So I'm making an API. We're getting to the same result. It's just I'm not dragging the workflow. I'm creating my API call, pull whatever our variable was, run this new one, inject that variable.
Yeah.
So
there's not a lot stopping us from getting to where you want us to be, but we don't have it built in the UI.
Just make the little picture, draw the little box, and you're done.
And we had that defined essentially. I'm forgetting our own terminology, but essentially like a kind of sub workflow where you could build a whole sequence of things, save those as an element, and then drag those in where it's a whole contained block of operations. And it will be reintroduced well, when I say reintroduced, it will be on the roadmap of the product for sure.